the example problems. So the 5 properties that we went over were that the opposite sides were parallel to each other, the opposite sides were congruent to each other, the opposite angles were congruent to each other, the consecutive angles, like angles B and C, were supplementary to each other, and then the diagonals bisected each other. So the diagonals themselves aren't congruent, but they are cutting each other in half. That's where we left off yesterday. So let's just look at a few examples with that. In letter A, we have 2 variables we're being asked to find. Let's first solve for x. So there's 2 angles here marked with x. So you have 2 options for how you're going to set up this equation. Either they equal each other or they equal 180. So you have to ask yourself, are those 2 angles opposites of each other, or are they consecutive and next to each other? So can someone raise their hand and tell me if those angles are opposite of each other or next to each other? Can someone raise their hand and tell me? Parker? They are next to each other. So they don't equal each other, plus C is obtuse and B is acute. So that wouldn't even make sense if you set them equal to each other. They're clearly not the same size. So they don't equal each other, but they do equal 180. Any of the angles inside of a parallelogram that are next to each other are going to be an example of consecutive interior angles. And just like in chapter 3, they're going to equal 180 together. So I'll go ahead and add those 2 angles together and set it equal to 180. And then solve. And then I already told you once you need a calculator, so if you don't have one, I'm going to be a little bit irritated. Okay, 8x plus 28x is 36x. So then divide by 36. And Tristan, let me know what 180 divided by 36 is. 5. Very good. Okay, so again, anytime they're going to mark up angles, and normally you're going to see it's going to have a little degree measure next to it, but anytime they mark up angles, they're either going to equal each other if they're in opposite corners, or they're going to equal 180 if they're next to each other. Those are your only 2 options in a parallelogram. Your sides here, this is a pair of opposite sides. Okay, the opposite sides from yesterday were parallel and congruent to each other. So if those are congruent to each other, then Faith, what kind of equation could I set up here? Very good. 3y minus 5 equals 13. And that is a 2-step equation that you can easily solve. So I'm going to give you a second here to solve that on your own. 2 steps. And Angel, what'd you get for y? Very good. Okay, if you add the 5 over, you get 3y equals 18 divided by 3, and you get 6. Nice job. So again, pretty much everything in this section, you're just setting things equal to each other, except when you have a pair of consecutive angles like that. So there were a couple problems on that 7.2 worksheet, I know, where you were dealing with some consecutive angle measures. Okay, B, you have some diagonals crisscrossing here. The diagonals don't equal each other directly, like AC is not the same length as B to D, because when it's a slanted figure, one will always be longer than the other, but they are cutting each other in half right here at this middle point. So AC is being split into 2 equal halves, and BD is being split into 2 equal halves. So we can start with either variable, it doesn't really matter here, but if I start with this diagonal, those 2 halves are equal to each other, so 4x has to equal 3x plus 3, and I'll solve that. And on the other side, these 2 halves equal each other, so 6 has to equal 3y, and then I'll solve that. So again, those are 2 pretty simple equations here, 1 step each. Connor, what do I do to solve for x for the left equation? Good, and I get 1x equals 3, but remember guys, 1x is the same as x. 1 times anything is the identity property. It just comes out to be exactly what it was. y, Michaela, what do we get for y here? Very good. Divide by 3 and we get y equals 2. Questions so far? Okay. We just have a couple graphing problems to finish, then we're going to move on to the 7.3 notes, which aren't a whole lot different than the 7.2. There is one on your homework like this, so let's go ahead and go through this one. It says, given ABCD is a parallelogram, solve for the missing angles and sides, give the theorem that supports your answer. This 40, by the way, right here, angle D is all of angle D. That gets a little bit confusing, so 40 is all of angle D. So again, there's 5 properties, really 4 properties we have to keep in mind here. The opposite sides are the same length, the diagonals are cutting each other in half, the opposite angles are the same measure, and the consecutive angles are supplementary. So we're going to start here with angle A. Okay. Grace, angles A and D, are those opposite angles or are those consecutive angles? Consecutive. So do they equal each other or equal 180? 180. Very good. So if I'm looking for angle A, I would just subtract away the 40 degrees because it has to be supplementary to any angle next to it. So if I take 180 minus 40, anybody, what do I get? 140. Okay, that's all of angle A. So angles B and C are going to follow suit here. Ashley, angle B, how do you think we can find the measure of angle B? I didn't hear a single thing you said. Oh, okay. What do we know about angles in a parallelogram? Huh? What equals 180? Okay, look at your notes, dear. So we'll go back to the notes, and on the first page, what did it say about the opposite angles of a parallelogram? They're congruent. And then the consecutive angles are supplementary. Ashley, which angle is opposite of angle B? Angle D. And how big is angle D?
40.
So how big is angle B?
40.
Very good. Okay, and I forgot to do the theorem up here. So when it says find the theorem that supports your answer, I don't actually want you to write like theorem 7.1 or whatever. Just write something like this, like consecutive angles equals 180. Opposite angles are congruent. Something like that. So pick one of the properties to defend your answer. And on your homework, you have to do that as well if you've been working ahead on the homework. And then finally, Aaron, I know you weren't here yesterday, but we'll see how you do with this. Angle C, Aaron, which angle is opposite of angle C? Angle A, so then how big is angle C? Exactly. Plus, it's consecutive with the ones next to it, D and B, so you could have taken 180 minus 40. But I'm going to go ahead and use the fact that opposite angles are congruent here to prove that it's 140. Good. Again, the angles in your parallelogram essentially need to be either equal to each other or equal to 180. Now, on the homework, there's a couple problems where they split the angle and give you just something like this and say it's 28 degrees. Well, that's a different situation, so you might have to ask about that one individually. Okay, then we have some side lengths to find up here. The first one we're going to find is AD. We learned yesterday the opposite sides of a parallelogram are equal. So Adam, which side is opposite of side AD?
BC.
BC. So how long is side AD?
5.
Very good. And then why? Because opposite sides are congruent. You only have 4 properties to pick from to defend your answer. Because the parallel lines don't really affect anything. Next is side CD. Side CD. And McKenna, what side is opposite of side CD? AB. So how long is CD? Very good. Okay, just like a rectangle, A parallelogram doesn't have to be rectangle, but a rectangle lives inside the parallelogram family. So just similar to a rectangle, your opposite sides are the same length. Then it asks finally for segment A to M. I wish I had like one more color marker. That's okay. A to M. The diagonals bisect each other and cut each other in half. So that means M is a midpoint between A and C. So eta, if M is a midpoint between A and C, and M to C is 3, how long is A to M? 3. And for your defense here, the theorem about diagonals was that the diagonals bisect each other. The diagonals bisect each other. So again, at the bottom of the worksheet on 7.2, there's a problem just like this. You're going to fill in some values and then defend with one of those properties of parallelograms from yesterday why you picked the value that you did. Questions so far? Lots of just things equaling each other. It's just lots of symmetrical pieces. Okay, this next one, let's just read the instructions carefully. We don't want to assume that we know what they're asking. It says, find the coordinates of the intersection of the diagonals. So the diagonals where they cross, they want that intersection point of that's a little parallelogram symbol, LMNO, with the vertices at 1, 4, 7, 4, 6, 0, and 0, 0. So 1, 4, 7, 4, 6, 0, 0, 0. They want to know where the intersection is of the diagonals. So I would start by drawing in the diagonals just to kind of eyeball where they cross. There's one diagonal. And there's another diagonal. Okay, so that kind of gives me a rough estimate of where maybe I think that they cross at. Okay, because when I do this problem and I'm trying to say that, oh, their intersection is at 0.86, I'm going to be like, nope, that's not even anywhere close to where they're crossing. So that's a good thing to do first, is draw them. Now, what do we know about the diagonals of a parallelogram? What was the property and the theorem that we learned? What was true about the diagonals of a parallelogram on this green note sheet? They bisect each other. They're cutting each other in half. So this point where they cross, wherever it may be, is the middle point for each diagonal. So let's just pick a diagonal here. Lakin, pick either LN or OM. Pick one for me. LN. If we can find the middle point between L and N, because they cut each other in half, that'll be exactly where these diagonals are crossing. So I'm going to find the midpoint of one of the diagonals. In this case, Lakin wants to find LN. And wherever that midpoint is, that has to be where the diagonals cross, because it has to cross at the midpoint of each diagonal. L was at 1, 4, N was at 6, 0. So if I use midpoint formula here, add the x's, divide by 2, add the y's, divide by 2, that should tell me exactly where these diagonals are crossing. So for my x coordinates, I know we do this all the time, but I'm going to ask anyway. Parker, what is the x coordinate of point L? 1. And what's the x coordinate of point N? 6. So I'm going to add 1 plus 6, divide by 2. That'll be my x coordinate of the point. And then, Caitlin, what are the y coordinates I'm going to add together? 4 and 0. Very good. Add 4 and 0 and divide by 2. And this will give me exactly where those diagonals are crossing. It's not here. Let's go. Anthony, what's 1 plus 6? And what's half of 7? Okay. And then Anthony, 4 plus 0? Cut in half? Very good. And yeah, that makes about sense to me. Here's 3, so 3 1/2 would be right here, and then it went up 2, and that's where the diagonals are crossing. So again, what we did there was find the middle point. You don't have to find the midpoint of each, because it's going to be the same coordinate. You just have to find the middle point of one of them, because the diagonal is being cut in half. So it's right smack dab in the middle. Questions on that? Yeah, you could use slope. So if I used slope from L to N, it went down 1, 2, 3, 4 over 1, 2, 3, 4, 5. So half of 4 is 2. I could go down 2. Half of 5 is 2 1/2 over 2 1/2, and there would be my point. Yeah, very good. Slope would work fine too. Yes, absolutely. Okay, I think we have one more graphing one, and then we'll move into the 7.3 notes, I think. Oh, there's a proof. We're going to skip the proof. I know you'll be upset about it. All right, this one's different. So we're not going to the same thing here. It says 3 vertices are given. Find the coordinates of the 4th vertex, y. Knowing what we know about parallelograms. So let's go ahead and just draw in. Don't connect them yet. Do not connect them. Just draw them in and label them. Now, this gets to be just a tiny bit tricky. It's very much tailored towards the visual people. We're not just going to connect them and make a random triangle. That's not what it says to do. It says there's going to be a 4th point, y, somewhere in here that makes this shape a parallelogram. Now, if you look at the order of the letters, W, X, Y, Z, that means that's how they're going to connect. W is going to connect to X, X is going to connect to Y, Y is going to connect to Z, Z is going to connect back to W. So what I can connect is I definitely know W is going to connect to X, so I can go ahead and connect that. Maybe a straight line would be good, though. X is going to connect to Y, and I don't know where Y is at, so I can't really do much with that. Y will connect to Z, don't know where Y is at, that doesn't help me, but then Z will connect back to W. So I know for sure that W connects to X and that Z is going to connect to W, but I'm missing this point X, or excuse me, Y, somewhere in here. That's going to close it off and make it a parallelogram. Okay, you think you got it? So you kind of have to think about where is Y going to go so that it makes a nice parallelogram shape. If I put it here, right, is that going to make a parallelogram? No, so you have to think about where is it going to go. Now here's how you can find exactly where it goes. You're going to use slope, all right? We know that the opposite sides of the parallelogram have to have the same slope because they have to be parallel. So if I look at the slope of W to Z, it went down 1 and over 1, 2, 3, 4, 5, right? It went down 1 and over 5 from W to Z. And there's more than one way to look at it here. I'm just picking W to Z. So I know that this point Y needs to go somewhere over here so that it has that exact same slope away from X because the opposite sides need to be parallel. So from W to Z, if I went down 1 and over 5, then from X to Y, I need to go down 1 and over 5. So if I start at X and go down 1 over 1, 2, 3, 4, 5, and connect okay, well, what just happened? I just lost a point here. Z is at 4, -4. Now, does it make a parallelogram? Yeah. So, and there's more than one way to think about it. I could have looked at like W to X and said, okay, it went left 2, up 1, 2, 3, 4, 5. So from Z to Y, it needs to go left 2, up 5. Very much a problem for visual people. And there's one like that on your homework as well. Questions so far? Okay, we're going to power through here and try and knock out this last section. We'll have some review time tomorrow before your quiz on Thursday, but this is not really, it's all the same stuff. You're still dealing with parallelograms, so don't fret too much about it. We're going to skip the proof, as disappointing as that may be for you. Trust me. Okay, so I think I said this yesterday, but your section 3 is really just the converse of section 2. In section 2, they say, okay, this shape is a parallelogram, find this length, or find x, or find the diagonal, or whatever. Now it's going to say what value of x makes this a parallelogram, or what makes this a parallelogram, what proves it's a parallelogram. And we're going to add one little theorem to it today, but let's just review real quick, and we just did the green note, so it's not too terribly far from your memory. The 5 properties we've talked about so far, or the 5 characteristics that make something a parallelogram. So what's one characteristic that makes a shape a parallelogram? Yes, it's a quadrilateral. Yes, it has 4 sides. That's not what I'm talking about. But of those theorems on your green notes from section 2, what are the 5 properties we talked about that are true about parallelograms? Luke, what's one? Okay, so we want to be really careful about the terminology here. So it has both pairs of opposite sides are parallel. I'm just going to put the parallel symbol if you're okay with that. Can I just put the parallel symbol? No answer? Hopefully that's okay. Okay, both pairs of opposite sides are parallel. What else is true about parallelograms? Okay, the diagonals bisect each other. Absolutely. Now, I am really picky about this wording. You have to say bisect each other. If you just say diagonals bisect, I'm going to ask you, bisecting what? Are they bisecting the sides? Are they bisecting the angles? Because neither of those facts are true. So you got to be real careful to say that they bisect each other. What else is true about parallelograms? Parker?
Maybe like the opposite ends create like a
So the diagonals bisect each other. We got that one in there. Connor? Okay, the opposite, so let me be careful again. Both pairs of opposite angles are congruent. We have to add the words both pairs because there will be a shape where we have one pair of opposite angles congruent. So both pairs of opposite angles are congruent. So that would be like, for example, angle A and angle C. What else? There's 2 more facts that are true about parallelograms. Savannah? Very good. The consecutive angles equal 180. Or are supplementary, however you want to word it. There's one more. I feel like we're missing one of the easy ones. What else is true about the opposite sides, you guys? They're parallel and also, Michaela? Congruent. Just like a rectangle. Oh, I did it again. Both pairs of opposite sides are congruent. Okay? So now we're going to take some of these and use them as ways to prove that a 4-sided figure is a parallelogram. Now there's one of them up here that doesn't actually prove anything about it being a parallelogram, and I'll give you a counterexample as to why. And then we're going to add a special theorem in its place. Okay, keep going. Okay, so the first two say, okay, if you can prove that both pairs of opposite sides are congruent in a quadrilateral, then that quadrilateral has to be some kind of parallelogram. Could be a rectangle, could be a square, could be a rhombus, could be just a normal parallelogram. But if you can prove that both pairs of opposite sides are congruent, keyword there, both, then it has to be a parallelogram. And then same thing with the angles. If you can prove that both pairs of opposite angles are congruent in a quadrilateral, then it has to be some kind of parallelogram. There's the first two. So the first set of problems here is not really different than it was in the blue or the green notes. It says find the values of x and y that make this a parallelogram. The green note said it is a parallelogram, find x and y, but it works the exact same way. So it looks like they're marking up some opposite sides here. And Luke, remind me, what's true about the opposite sides of a parallelogram? They're the same. They're the exact same length. So that means that x plus 9 and 2x minus 1 are the same. And y and x plus 7 are the same. The opposite sides are exactly the same length, just like a rectangle. Now, I would argue that one of those equations you probably need to solve first before you do anything else. And Jacob, which equation do you think I have to solve first? The left side, because the right side has an x and a y in it, and so that's not going to get me too far. So let's go ahead and solve for the left side first and get our value for x. So I minus the x over to the right side. So you get 9 equals x minus 1. Add 1 over to the left, and I get x equals 10. And what do you suppose I can do with that 10 to help me solve the right equation? Luke? Okay, what do we call that property? What do you call it when you plug in like that? Very good, Aaliyah, thank you. Substitution. And 10 plus 7 is 17. So not really different from the first set of notes. Can I skip the second example for the sake of time?
Yes.
Okay. Opposite sides are equal. Keep that in your head, just like a rectangle. Two other ways to prove something's a parallelogram. The first theorem, if you can find one pair of sides that are both congruent and parallel, then it has to be a parallelogram. So that's a little bit new. It's not really a property so much as just a way to prove it. If you can find one pair of sides that are both congruent and parallel, then it has to be a parallelogram. And then the last one here is not new. If you can find some diagonals that cut each other in half, then it has to be a parallelogram. And this problem says, for what value of x is quadrilateral CDEF a parallelogram? Well, if it's a parallelogram, then these diagonals are going to cut each other in half, making the 3x and the 5x minus 8 equal. So if they want to know what value of x makes this a parallelogram, let's go ahead and set them equal and solve. Again, even though the directions sound a little bit different, it's not really operated any differently than it was on the section 2 notes. And Benny, what would my first step be here to solve for x? Or what would you do first? Okay. And that's fine. We can add 8, but let's just keep in mind it does not combine to the 3x. So all we've really done is just shifted the 8 over to the right side and made it positive, which is fine. But it didn't combine to anything. Just be clear about that. So then from here, what can we do? Benny? Or, sorry, Luke? Subtract 3x. You get 2x equals 8. And then we never miss the division part. X equals 4. Okay, otherwise, in the beginning, you could have just minus the 5x over and gotten negative 8 equals negative 2x and then divide right away. Good. Don't have to plug 4 back in. It just says what value of x makes it a parallelogram. almost done. We're going to keep powering through here. The next one says same thing. For what values of x and y is quadrilateral ABCD a parallelogram? Explain your reasoning. So the consecutive angle thing doesn't actually prove anything about a parallelogram because there are other quadrilaterals that have consecutive angles that are supplementary, so we can't go that route. But regarding the angles, one of the ways to prove it's a parallelogram is if we can prove that the opposite angles are congruent to each other. So if we look at this picture here, Aaliyah, can you point out a pair of opposite angles? Okay, A and C. So if this is a parallelogram, then those two angles should equal each other. And then my other pair should also equal each other. And then I'll solve for each. I'm going to do this quickly because I don't have time to spend time on algebra, so I'm going to minus the 3x over. I get negative 32 equals negative 1x. Divide by negative 1, which just makes the 32 positive. Lots of just setting things equal to each other and solving. I'm going to minus the y over. I get 3y equals 87. Divide by 3. Ooh, 87 divided by 3. 29. Questions on the algebra part of it so far? Okay, that's the easy part. The next part is going to be not as straightforward. It's because you're not actually getting an answer for something like an x equals 4 or y equals 2 or whatever. It says state the theorem you can use to show that it's a parallelogram. Now, if you guys look beneath on your note sheet, all 5 theorems are sitting right here. These are the 5 ways to prove something is a parallelogram. Now, the list looks a lot like the 5 characteristics of a parallelogram, except they've taken off the one about consecutive angles and added the 4th one on this list that says show that one pair of opposite sides are congruent and parallel. So you have to decide, of these pictures up here, which theorem are they using of this list of 5? These are your only options. What does it really match? Which theorem does it match on this blue paper right here? So the first one, if we look at that picture, first of all, what do those arrows mean right there? Parallel, okay? So we have a pair of parallel sides that are opposite that are also both 30. So I'll open this one up for a volunteer answer. Which theorem do we think defends why that has to be a parallelogram? Parker? 4. Number 4. I would agree with that. Now, I don't want you to just write number 4 because on the test I won't know, like there is no actual specific order. So let's just go ahead and say here, one pair of opposite sides are congruent and parallel. But he's exactly right. Number 4. Show that one pair of opposite sides are congruent and parallel. The wording there, all of it's important. You have to say one pair. You have to say both congruent and parallel. Or equal. I wouldn't care to put equal. Okay. So Michael, if we look at the second one, where they're showing this pair of opposite sides are 7 and 7, this pair of opposite sides are 5 and 5, which theorem, and you can just give me a number, do you think matches why B has to be a parallelogram?
Talking to me.
Uh-huh, that's what Michael. Number 2, both pairs of opposite sides are congruent to each other. So again, we have to be very deliberate about how we're wording this. Both pairs of opposite sides, they are not angles, are congruent. Both pairs, you can't just put opposite sides congruent. Both pairs. You have to add those 2 words in there. And then the last one, with these angles, Kendall, which theorem do you think of this list of 5 matches why C has to be a parallelogram? 3. Very good. Show that both pairs of opposite sides or opposite angles are congruent. Awesome. Both pairs of opposite angles are congruent. Absolutely. Nice job. So again, you can't just put 1, 2, 3, 4, or 5. You have to use this list as your reference, but you have to actually label the reason correctly. Okay, let's go ahead and save the graph one. It is important because you will have to do that on your quiz. Let's save the graph one for tomorrow. We'll start class tomorrow with that. For tonight, 7-2, 7-3. I know it's a lot of homework. Please, please, please try and get all this completed. We have now completed, for the most part, sections 1 through 3. We have just the graphing to finish tomorrow on this. Okay, you still have over 5 minutes, so make sure you are working on this worksheet. I think most of the worksheets will go fast for you.